Hello everyone and welcome back to another tutorial. In today's video, we'll be learning how to interface an IR proximity sensor with Arduino and display its reading on 20x4 LCD. All this will be done in the Proteus. This project is a perfect example of for those who want to learn the object detection, sensor calibration, real-time display of analog values, and other projects in the Proteus. The project uses an IR sensor to detect objects based on the reflected infrared lights. The readings are then processed by the Arduino, and after processing, the output is shown on 20x4 LCD. We also make the output stable using the average and hysteresis in the code so it does not fluctuate when the object is near the threshold. This setup can be applied in robotics, line following system, obstacle detection projects, and multiple others. Let me tell you something about the module. The IR tracker sensor emits infrared light and measures the reflection from the nearby object. The sensor provides an analog voltage that is proportional to the reflected light. In Proteus, we are using the potentiometer on the module that will let you to adjust the sensitivity, allowing it to detect the object more accurately under different conditions. The analog signal is read by Arduino's A0 pin for the processing. Before moving towards the simulation, you must have to install three basic libraries of the Proteus. As you can see here, the first one is obviously the IR proximity sensor. The second one is the new LCD library, and the third one is the Arduino library. I will provide the link of all these in the description. Once you have installed it, you are ready to create the circuit that I have created before starting this video. As you can see, this is the sensor, this is the Arduino module, and this is the LCD. If I tell you more about the sensor, it has three main pins. This is the output pin connected to the LC circuit. Actually, the LC circuit is only used in the Proteus simulation, not in the real-time project. But in Proteus, we need this so that it may conduct the current and other parameters naturally that are real to the real world values. This is the ground pin and this is the power pin. The test pin will allow us to change the value of this potentiometer. The resistance of the potentiometer in this project here in the Proteus means the user is inputting that the object is near or far to the module, and once the values are changed, the output in the analog pin also change, and that change is then attached to the Arduino. This is the analog pin of the Arduino. Arduino process the voltage changes and then convert them into the change in the IR proximity, and the whole result is shown then on the LCD. So to make it workable, we need to control the Arduino through the code, and for this I'm using the Arduino IDE. Make sure you also have the LCD library to start this project in the Arduino IDE. Let me tell you what is going on in the code. So this is the liquid crystal library that will allow us to use all the features of LCD. Then we are defining the pins of LCD that are connected to the Arduino. After that, this is the definition of the analog pin of the sensor that is connected to the microcontroller. See, this is A0. This is A0 of microcontroller. After that, we have initialized and declared three main values that are the threshold value, the sensor value variable, and the last status. Okay. In Arduino coding, the void setup is processed only one. So I have provided the introduction of this project in this part. So this will the project will show the introduction or the title of this project at only once this part is complete, the Arduino will move towards the loop function and will continuously read this. So the Arduino is continuously reading the values input by the user and looking at the resistance value, comparing it, and then converting it into the meaningful values that can be displayed on the LCD. So once this is done, we have to create a connection between the Arduino code and the simulation. So what am I doing? I will be needing the hex file address. Whenever we compile the code in our system for the first time, it creates a hex file in our laptop or computer. We just have to provide the path of that computer's file into the microcontroller. So to do this, I have compiled the code and now I am searching for the address it has provided me along with other information. As you can see here, this is the hex file address ending with .hex extension. I'm just copying it. See, copying it, coming to my simulation, clicking on the Arduino and pasting it here as I have done it before and click OK. Now there is a connection between our code and the microcontroller. But if you are using the sensor for the first time, you will also have to provide the hex file to this module. So the process is the same. Double click on it and click on this icon and direct it to the library folder of your computer. See, the sensor's path is here. Click OK. And now our project is ready to test. So this is the title or the introduction of this project. As I have told you, it was mentioned in the setup function. At the moment, the value of potentiometer, I will show you zooming in, is 100%. So the same value output result is shown here on the voltmeter, and the same is shown here on the LCD. So at the moment, what this project is doing, it is saying that an object is very near to the sensor and the object is detected. It has the analog value, as you can see here. This is the maximum. Let me change it. I'm inputting the 0% resistance, and you can see that it say that the analog value is 0 and the status is no object in the range of the sensor, and here the volt is also 0. I hope this project will help you and the video was helpful to understand the whole system. If you have any question, you can ask in the comment section.